Okay, so today's video is on solving right triangles using trigonometry. This is a quick review of what it is that we covered today in class. So when we're solving right triangles using trigonometry, there are some basic steps that we want to follow every single time. The first thing that we want to do is we want to be able to identify the reference angle in our diagram. The reference angle is always an acute angle, and it's the one that is given to you, so I don't want to have to calculate one. The reference angle may never be the right angle. So in this diagram, A is the reference angle. From here, we now want to label the three sides of the triangle with the labels opposite, adjacent, and hypotenuse based off of the angle that we're referring to, which is A. So the hypotenuse is always going to be the side across from the 90, so that'll be this guy over here. And then this x right here is the adjacent because it is next to the angle A. And this side over here is across from angle A, so this would be opposite. Now I'm currently solving for two variables in this question, the x and the y. So as a result, I'm going to choose to just pick one of them, solve for first. So I'm going to start with solving for x. Usually there's one variable. When you have to find all parts of the triangle that's missing, we call that solving the entire triangle. So if I'm choosing to solve for x first, I look at my diagram and I want to figure out which function do I have going on here. So I try to remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. I see that in terms of x, I have the following. I have that theta equals 32. I have that the hypotenuse is 7. And what I need, what I'm looking to solve for, is x, which is adjacent. So I kind of think about this. I am thinking I have hypotenuse and I need adjacent, so I want to figure out which function is that. The function that involves hypotenuse and adjacent is cosine right here, so I'm going to write a cosine equation. So I'm going to say the cosine of my angle, which in this case is 32, equals adjacent, which is x, over hypotenuse, which is 7. So I've just written my trig equation. That's step 4. To solve a trig equation, just like any other kind of equation, in order to solve, we need to isolate the variable, which means to get it by itself. So to show my work here, I'm going to say, okay, this is x divided by 7. So if I multiply by 7 on both sides, I will clear out this denominator 7. Whatever I do to one side, I do to the other. So now I can go back to my blue. So I now have that 7 times the cosine of 32 equals x. And again, reminder, I always want to put my number in front of my cosine or sine value because I don't want it to appear as if I'm multiplying the angle by that quantity. Once I get to this step, I go to my calculator, and on my calculator, which we've changed into degree mode, I just literally type in 7 cosine 32 and I hit enter. It's going to give me a decimal value. We're going to go 2 places after the decimal on average. So I'm going to say that this comes out to be 5.94. It's approximately because I'm rounding. So the value of my x is 5.94. If I want to solve for y, I can do a very similar thing, but to solve for y, we would say that we have that theta is 32, we have that hypotenuse is 7, and what we need here is y, which is opposite. So I have hypotenuse and opposite. Those combine to give me sine. So I'm going to write a sine equation. The sine of 32 degrees equals opposite y over hypotenuse 7. To get the y alone, again, I would multiply to clear out that denominator. So I have that 7 times the sine of 32 is equivalent to my value of y. And again, I go to my calculator and I just hit 7 sine 32, enter. And it tells me it's about 3.71, whatever the units are, inches, centimeters, etc. Additionally, once I solved for x, I technically knew two sides of my right triangle, so I could have used Pythagorean theorem to solve for y. I like using the trig because it gives me a more exact answer. As we're looking at these notes, we do see that in the last step I said, step 7, if you're solving for an angle, use an inverse function. Just want to look at one example of what happens if you're solving for an angle. So this question wants us to solve for a measure of angle A, so I'm going to put an x there. That's my reference. So in relationship to this angle, this side is across from, so this is opposite. And this is across from the 90, so that makes this side hypotenuse. So again, we're thinking, which one of my functions is that? So we have SOHCAHTOA. So in this example, we have that the opposite equals 2 and that the hypotenuse equals 10. And what we need is theta, which is x. So opposite and hypotenuse, again, is a sine equation. So I'm going to write my sine equation. I'm going to say the sine of some unknown angle, which we represent with x, equals opposite 2 over hypotenuse 10. Now we can't divide by sine. Sine doesn't have a numeric value. It's just saying it's the ratio of opposite over hypotenuse for that angle. So we need to undo sine. To undo a function, we use its inverse. So I am going to go ahead and take the inverse sine of both sides of this equation. And it's not a multiplication, it's an undoing, so its location matters, which is why I wrote it out in front. So on this side, sine inverse and sine cancel each other out. So I end up with x equals, and on this side I just leave the notation sine inverse of 2 over 10. So on your graphing calculator, you'll see above this button that says sine, it says sine minus 1. That's the inverse of sine. So on your calculator, you're going to do second sine and then just enter 2 divided by 10. And when I do that on my calculator and hit enter, I get an answer. It tells me x is about equal to 11.54. And this is my angle, so that's going to be in degrees. And those are the ways that we can solve right triangles using trigonometry.